Okay, so hi everyone. Today we're going to solve another problem, that is LeetCode 97 interleaving string. It's a medium level problem and it has a very good like to dislike ratio. So let's start. So we are given three strings, that is S1, S2 and S3. Now we need to find whether S3 is formed by an interleaving of S1 and S2. So what do we mean by interleaving? For example, let's consider this test case. A, and then you have B, C, C. Right, so this is your S1 and your S2. Let's say we have S1 of this color, that is red. S1 string is A, and then you have B, C, C, right? And then you have string S2, which is of pink color, which is D, B, B, and CA. And then you have string S3. So S3 is A, D, B, B, C, B, C, AC, right? And now you need to select these you need to, let's say that we need to merge these strings together in such a way that their relative order is maintained, and after merging them they should give me this string, right? That is the interleaving. That is what interleaving means. So the first condition is, if the S1 length, the first condition is if we need to calculate the S3 length. So S3 length is obviously going to be equal to S1 length plus of S2 length, right? Makes sense that they need to be equal, right? So this is the first condition. Now let's see if their lengths are equal. This is A, 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So the S3 should be equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fine. First condition is pass. So let's move on. Now let's check if we can have these characters. So yes, A, we can have this character, that is A. So we are beginning from both of the strings and the first character is A. So I will say that I will take A from string 1, and then the next character is this A. And now because I have taken the string from A, I will increment this string. Now I need to get another A, and where can I find this A? In string 1 again, because string 2 is offering D. So I will take string 1A again, and now this pointer is incremented. So now this is B, this is D, but what we are looking for is D, which means string 2 is now offering. So I will take this pointer, increment it, and now this is replaced with D, because ping says that it is given by string 2. And now you have so now it will be incremented, and now you are at B. So now you have a problem. String 1 is also giving you B as well as string 2. Which should we take? Now there is no greedy approach, because there is no practical proof that if you take only this particular string character, then your answer is guaranteed to be accepted. There is no proof for that, which means we cannot apply a greedy approach for this problem. So if we cannot apply a greedy approach and we cannot give a proof to any certain step that we are doing, which means we need to travel all these steps, right? Which means it is now a recursive problem. So if it is a recursive problem, now you can see that at this position, this string will have two occurrences. So two paths, let's say. So one path and other path. So one path is if I take S1 character and if I take S2 character. So if I take S1 character B, then this will be B, right? And the white characters are, so the characters are A, D, B. Yes, now you have B, C and B, C, A, C. And from here on, you will say that I have taken a pink character B, and the remaining are B, C, B, C, A, C. So now let's solve them. So if I have taken, now let's solve for the S1. So if I have taken S1, which means this should be incremented, right? So this will be, the pointer for S1 will be pointing on C character. And now you have B, and here you have B, which means that this B is something that we are obtaining from S2. So I will mark it as pink. Now you will increment this pointer again. Now you are pointing at B. The next character is C, which is offered by S1. So we will move this pointer to this part, and this is C is given by S1. And then you have B, and B is offered by S2. Sorry, yeah, S2, which means that this increments the pointer, and this B is colored pink because it's given from by S2. And now you have C and C. Again, there's a problem. So at this point, you have two options, either to take S1C or to take S2C. So if you take S1C, in that scenario, this will be, if you take, yeah, the characters that are left with you are CAC. And if you take only this part, then this will be C. Okay, makes sense. And if you take this C, then it will be C again. And the white characters are AC and AC. Now we are looking for, so now this pointer is exhausted, right? And I'm pointing on this character. Now I'm looking for A. Well, this string is given me an empty string, and this string is given me C. I cannot find A, which means that my decision for taking this C is wrong. I should backtrack it, and I should consider that S1 will not give me a correct answer. Okay, so now we'll backtrack to this part, and I have taken, the BC, the C from the second string, which means C is now pointing here. And at this point, and C is pointing here for this character. And at this point, I say that this, I have taken A, and now I am requiring A, right? And this A is provided by S2, which means this pointer is incremented, and A is now changed to pink A because it's provided by S2. And this C is something that is provided by, sorry, the C is pointing on this point. Yeah. So this C is something that is provided by the last character, which means this is a red C, right? And you will see that, and now this pointer is also exhausted. This pointer is also exhausted. So now there's a clear observation that if we follow this path, that take A and D. So where should I take A? I should take A and A from S1, and then I should take D from S2 because there's only one way of taking this D. And then when I take B, I should take B from S1, right? And then I should take B because there's a B in the second string, then C, then B. Okay, so this B, yeah, then I should take B, and then the next part is C, and C should be taken from second string, and then you have A and C. So this is one way of forming it, right? And there could be another way, but we need to return true if we find it. So you can clearly observe that it can be solved with recursion. So let's write a recursive code for this problem. I think now this is basically the recursive tree. So I think it's now making sense that why recursion is used and how it is used in order to get the answer. So let's implement it. So the first thing is return, let's say solve S1, S2, S3, and their indices, that is 0. All of them are initialized with 0. And now I have a bool function because it's a boolean value, it's returning a boolean value. So solve string reference S1, string reference S2, string reference S3. And another thing is their indexes. So I will say int I, j, and k. And for a reference, I should write here the indices. So I is for string 1, j is for string 2, and k is for string 3. So the first thing is the base case. The base case will be if we are at the S3, if we are at the last part of the S3 and we have exhausted the S3, which means we have found all the characters from S1 and S2. So that condition will be if k is equal to S3 dot size and I is also equal to s1 dot size, which means I is also exhausted, k is also exhausted, and j is also exhausted, which means all of the characters that are given to us from string 1, string 2, string 3 are taken into consideration for the interleaving process, and it's a matching string, which means that j is also equal to s2 dot size, which means it's a good case and it should return true value. Otherwise, now there are some states. So this is a confused, or um let's say a confused state, right? So in this state you have two options: either you can take the b from string 1, or you can also take b from string 2. So what you will do is you will say that if I is less than s1 dot size and j is less than s2 dot size, and because you are going to check both of their indexes, right? So the thing is, if s1 of I is equal to s2 of j, right? So this is the condition if you are getting same characters from both of the strings, and s1 of I, that character which you are getting from the string is equal to s3 of k, right? This makes it a confused state. So for this state you will say that we need to solve for both of them, which means s1, s2, s3 as it is. And now if you are solving for if you are taking I, right, you will say that for this state where I'm confused that I should take a character from string 1 or string 2, I will now solve for that case where I take a character from string 1, and if it doesn't work out, then I will solve for the other case, that is taking the character from string 2. So if you take the characters from string 1, it will be I plus 1, so I will be incremented, and j as it is, and k have to be incremented regardless. And similarly solve, now we're going to solve for the another case, right, where we don't take we don't take the character from the first string, which means I should remain as it is, and j is now incremented because we take the character from s2, and k is remain incremented regardless. So this is one case of doing it, right? Now other thing is, if you are not in a confused state, which means you are getting a character from string 1. So if you are getting a character from string 1, again this situation, I mean this case has to be checked. And yeah, so the case is if I is less than s1 and s1 of I is equal to s3 of k. If this is the case, then it means that we are taking the character from string 1, so we will solve s1, s2 and s3. Now I is incremented because we are taking the ith element, so we need to increment it, and j as it is because we are not doing anything with the string 2, and k have to be incremented. And yes, and another case is if you are taking the character from string 2, in that case j has to be less than s2 dot size, and s2 of j character should be equal to s3 of k character. Return solve s1, s2, s3. Now I as it is j plus 1 and k plus 1, right? Now the last case is, so see, if you are not in this good case where you are returning that all of the hard work has been done and we have found our string and it is interleaving, if we are not in this case, okay fine, which means that we are still processing, struggling for the answer, and we may be in a confused state. Okay, so if we are not even in a confused state, then we could be in a state where, then we could be in a situation where we are getting the element from the, or the character from the string 1. And if we are not even in the that condition that we are getting the situation, we are getting the character from the string 1, then we might be getting the character from s2, right? But if a case is that we are not getting a character from either string 1 or string 2, so in that case there is no other way of solving it, we just simply return false, right? And that will make up our answer. So obviously this will not work because it's a, yeah, so this is the length that is 200, right? And there could be 2 raised to the power 200, I mean time complexity is 2 raised to the power 200, which means it will not work. That's fine. Okay, we need another base case. I think that will give you a wrong answer. Well, there is no wrong answer, but yeah, the base case is if the string length, that is s1 dot size plus s1 dot size plus s2 dot size. If it is not equal to s3 dot size, then there's no point of making this processing. We can just simply return false because this condition needs to be satisfied. Now the time is getting, obviously time limit exceed of problem. And why it is so? Because let's say if you have a worst case where for every character x you are making these choices, and for every character y you are making these choices, so this will give you 2 raised to the power n, and the 200 is size of the string 3, which means this will give you the time complexity of 2 raised to the power of 200, which is very very large number. And this will give you TLE regardless, even if you have 2 seconds of time, right? So how to optimize it? Now, in order to optimize the plain recursion like this exponential recursion, we can do something, and that is dynamic programming. How to do it? Let's see. So I will say that how many variables are there? I want you to observe how many variables are there. There are 3 variables that are transitioning into another state, right? Which means that we will be having a vector, 3D vector, not bool actually, int. And this is dp, and size is s1 dot size plus 1, because we will be keeping the check of the last, that is the nth element, I mean the n plus 1th index as well, that will be included, so that is why n plus 1. And then you have vector int and s2 dot size plus 1, and then you have a vector of int with size as s3 dot size plus 1, and the last character, that is minus 1, right? Let me check parentheses are okay. So this is the dp 3D dp that we are using. I will pass it as an argument here as well. And the last thing is we need to have a base case for dp. So if the value is already memoized, so what do I mean by dp of I, j and k? These are the variables that we need to check, which will be changing. And if it is not equal to minus 1, which means we have the value memoized and we can use that value. So we'll say dp of I, j and k, right? And in all other cases, I will be memoizing the value, storing that value. So dp of I, j and k is equal to this value, right? And I also need to pass the dp as an argument in the function calls. So it's dp and dp, right? Yes, I think it should work, but let's see. Let's try submitting it. Okay, it does work, and it is not performing very well. Let's optimize it, obviously. So to optimize it, let's see. You know what? These are the variables. That is I plus j is equal to k, right? This is the obviously this is a relation, right? Because if we have taken, let's say if this is a string which has these many characters, string 1, and string 2 has 3 characters, and it has 4 characters, and it has 3 characters, and the string 3 will be having 7 characters. So if I have taken only 2 characters from this point, and I have taken only 1 character from this point, which means that we have built only third characters. So we have built only third characters in the S3, in the interleaving string. So this is the relationship that we only have 2 independent variables. I mean, from this observation, you can see we only have 2 independent variables. So if you have a value of I and you have a value of j, you can have value of k, right? Which means you don't need to have a 3D DP, you can do it in 2D DP as well by using only two variables. That could be ij, that could be ik, and that could be jk. So this is an important observation that we will use for further optimization as well. So if we are just using it for, you know, two variables, so these are some of the implementation changes that needs to be done. And let's solve it for S1 and S2. Okay. And the last part is this one. Okay. So now we need to change this K. Yes. Now you have DP of ij. Looking good. Let's see if the test cases will pass. Okay, they do. And let's try submitting it then. Yeah, it passes. And it is quite optimized, I will say, because I think the previous solution had 30 millisecond or 60, I don't know, but 60% beat ratio and 20 or 30 millisecond time. So this is an optimal way, right? But is there any other way? Obviously, because this is a top down DP. And yeah, the time complexity. So time complexity for the DP solution will be n into m, and space complexity and time complexity both will be this only. Why we are using space complexity? First of all, recursive call stack, and then you are also using a DP data structure that is a 2D matrix, which is n into m. So n is the size. Rather than saying n into m, let's just say s1 size dot s2 size, right? So this is the time complexity for the DP solution, and space complexity as well. So I'm not going to optimize it, but there's another approach, and that is to reduce the recursive stack, right? Because the time complexity will be same, but in this solution, the top down solution, we are using a recursive stack which has its own call stack space taking method or whatever. So we can obviously optimize from it. So for that purpose, we will be using or doing a bottom up approach. So the bottom up approach will also have this vector, this DP data structure, but it will be a Boolean value, although it can be integer as well, but I'm taking Boolean value, and every value is initialized with false value. And yeah, so in this case, what I will do is I will have two loops starting from 0, and then they are equal to s1 dot size, another loop that is equal to j is equal to 0, and j is less than equal to s2 dot size, and j plus plus. Now there are some conditions. The conditions are if I is equal to 0 and j is equal to 0. Now what does this mean? If I is 0 and j is 0, so basically this I and j, these are not really indexes, because we are using an equation sign in the condition part of the for loop. These are the number of characters that I can take from string 1, that is I, and from string 2 is j. These are those values. So if I is equal to 0 and j is equal to 0, what does this mean? This means that we are not taking anything from string 1 and string 2. What will be the interleaving string? It will be an empty string. And yes, they are making an empty string, which means dp of I and j is equal to true. We can have an interleave string with 0 characters from s1 and s2. Else if I is equal to 0 but j is not equal to 0, in that case we need to check for the I part, and that is dp of I j is equal to, so first of all, because we are checking for I part, we'll be checking dp of I and j minus 1, right? And the string that will be checked will be s2, right? Because from I'm saying that I'm not taking any element from string 1, so basically I need to check string 2. So that will be s2 of j minus 1, because it's a number of elements, so we need to minus 1 in order to access the index should be equal to S3 of I plus j minus 1, right? This is the condition. And else if j is 0 but I is not equal to 0, in that case I'm saying that I'm not taking anything from the second string, but I'm taking something from the taking some character from the first string. So I'll say dp of I j is equal to dp of I minus 1 and j minus 1, sorry, not j minus 1, j as it is, and s1 of I minus 1 is equal to s3 of I plus j minus 1, right? Now another case is else. Okay, so in this case you will say that this could be a confused case, right? So in the confused case you have two options. So you will say dp of I j is equal to, the first thing is dp of I minus 1 and j and the first string, right? So basically this is very much like this whole line. So it will check for this condition, and if this condition is false, then it will check for this condition. And if any of them comes out to be true, then dp of ij will be true, which means this combination is true, because because taking the string or character from the other part is satisfying the condition, which means that we can have an interleaving string from this combination of I and j. That's what it means. Now after this part, if we want to get the answer, I will say dp of s1 dot size and s2 dot size, right? So let's try first of all we need to try the test cases. It's true, let's try submitting it, and it worked. Okay, not performing idly well because the top down the last top down method was, I think, 7 millisecond. Yeah, but it's fine. We have learned this approach, that is the bottom up. Now there's a question: do we really need two variables? Like, do we really need two variables? Can we not do it in just one variable? Yes, we can. You know how? So if you have I plus, yeah, from this consideration you can see I and j, these two variables will give you the value of k, right? I and k will give you the value of j, j and k will give you the value of I, which means that these two variables, right, they are independent, but we need only to store the variable from string 1 or string 2. Only storing the occurrences or the chances of string 1 and string 2 can also solve the problem, right? So what do we mean by that? Let's prove it. So we have dp vector of bool only s1 dot size. Well, s1 dot size could be a problem, so let's not. Well, yeah, s1 dot size could be a problem, but because we are using a j loop, because we need to swap the loops. But yeah, I will do it. Let's see what we will be left with. So I'll be using s1 dot size plus 1 for this dp. Now we need to traverse on the string, right? So this should be I, this should be I, this should be 1 obviously, and this should be I, and obviously this should be j, right? Now the first condition is, now okay, in all these occurrences this j should be removed. Yes, so dp of I is equal to true. Fine, this will work. Now if I is equal to 0, then dp of I is equal to this j is not required now, right? And this condition will be checked. Now this condition says that s2 of j minus 1 and this value I plus j, and this value will stay as it is. And the other condition, if j is equal to 0, then we don't need j here. The previous value of the I will be checked, string 1 and I minus 1, and this condition is then satisfied. Similarly for this case, we have dp of I that is equal to dp of j is not required, J is not required now. So yes, I think this no, yes, this should also work. Now this is a 1D DP. Yes, and it does work, and it is the fastest till now. And yeah, so this is it. So you must be wondering how we get to work, how we are working with 1D DP only. So the thing is, for every ith character, you can make an observation that either you will get a string from this ith character, interleaving string, or not. So if you will say that for this example, right, why we need to store these occurrences, we can only say that okay, this b should not be taken, right, because we are finding the first string that could give us the value. And we can also actually apply BFS, and I might give you another solution video where we are working on this solution with the BFS approach, but for this one I will be going with DP. But the single case says that either this value should be taken or not taken, this value should be taken or not taken, right? So every ith character will have a true or false value if this should be taken or not taken, right? So if it is a true value, which means the previous value could be taken and we can have our answer. If it is false, then we cannot take it. This is a simple observation. And yeah, so the time complexity for this one, the time complexity for the last approach is still s1 dot s2, right? But space complexity is optimized. So space complexity is minimum of s1 comma s2. And how to get the minimum of s1 comma s2? After this base case, I can have another case, that is if s1 dot size is smaller than s2 dot size, then return is interleave string function. And yeah, so I'm choosing s1, right, which means if s2 is smaller than s1, then it should be swapped. It should be s2 and s1 and s3 as it is. So this will swap the values. If s2 is smaller, then it will swap it, and we will have the time complexity as this, that is a minimum of s1 and s2. Yes, now it's performing way better in the time and space complexities. So yeah, so this was the problem, and the solution we have looked at, I think, 4 solutions. So one was the plain recursion, then we have 3D DP, then we optimize it to 2D DP, and then we optimize to 2D DP bottom up, and then we have single 1D DP bottom up. And I think 2D DP and 1D DP can also be applied to the recursive top down part as well. But just for this part, I think this is all done. And so yeah, this was the solution. I hope it was helpful to you. And yeah, thanks for watching. Have a good day. Bye everyone.